Okay. Sorry. When we look at, I think I've explained this, to find a key. Okay. When you look at the previous class, we talked about placing something. Now I want to explain it further. Now, to find a key that does not exist, the system will continue the backtracking movement until it will get to the index 0, and then continue from the maximum index until that empty space that defines the point when the hash table is declared full is found. So if the key is not found when it gets to the empty space, it means that the key does not exist in that table. All right. Now, when we incidentally delete any key, it is replaced. We replace it with a particular character that we will define for ourselves. So, example, you may have an exclamation mark to place in that place. Now, the essence of that is that if you are searching for a particular value and you come to that particular point where a key was deleted from, you know that actually you have not come to the end of the list, and so you can continue to search. But if you deleted an item and nothing was used to replace that item, what it means is that the system will erroneously think that you have come to the end of the hash table when you meet an empty space. Okay, and that is actually the reason why you have to replace it with an exclamation mark, so that on encountering the replacement character, the system understands that there are still places to search for in the hash table. Okay, now the two major problems that is associated with linear probing is the primary and secondary clustering. Now, the primary clustering occurs when hash functions of two keys evaluate to the same index. Say that GLA has index 5 and next key was JFK, which also evaluates to index 5. Now, this phenomenon, when you start to use the backtracking methodology to place these values, this phenomenon will create a continuous block of field slots that will need to be checked before an insertion is made. And this is because the block keep growing until it hits the end. Okay, so that is when we have primary clustering. But secondary clustering will occur when the primary clusters grow to the point that the same primary location is hit repeatedly, or when anything that is part of that same cluster is hit. Now, this phenomenon will adversely affect the searching of keys in the hash table. So that's the two major problems that is associated with using the linear probing approach to creating your hash table. Now, the major way to deal with this issue is actually to do double hashing. In the first hashing, we used this particular formula where we evaluated the key by actually getting the remainder, the modulus of the key when we apply the hash function. When we divided the key, and the hashing equation resulted to the value that we used as the index location. Okay, now in secondary hash function, instead of actually doing the modulus division, we are going to do the integer division. Now, when you divide the integer, whatever that is the value here is what you use to see if you can place it. Now, when the value here, let's call it x, is greater than the 11, which is actually the space, the available space that you have, what it means is that you're also going to do a modulus division upon that stuff. Now, if we divided x, for instance, by 11, and the integer division gave us 13, all right, we noted that 13 is greater than 11. So what we are going to do is to subject 13 to division by 11 and take the modulus. Now, if we do this, we are going to have 2. Okay, so with this, we are using this particular value now. This particular value is actually derived by applying our secondary hash function on it. So it gives us the value that we can use to traverse, to jump. Okay, we say that double hashing involves creating a secondary hash function that will tell us how many slots that will be jumped to look for an empty space if the primary position has been filled already. Okay, so with this now, instead of traversing the lists one by one, we are going to traverse the list 2 spaces at a go. All right, and by this we have the opportunity to actually maybe overcome the issue of collision. All right, so if the integer division is done and the result is more than the indexing space available, then we divide again by the number of available space